Hi everyone, Mr. Chaffee here for today's lesson on systems of linear inequalities. We're going to start off by graphing some linear inequalities with two variables in them. Last week we took a look at graphing some inequalities with one variable, and we would plot those on number lines to shade in the corresponding solutions. Here we're going to take a look at two variable inequalities and graph them on a Cartesian plane so we can see how they're represented in two dimensions. So getting started with number one, the first thing to do is to rewrite each of these in slope-intercept form. That makes these a little bit easier to graph. This one is already written in slope-intercept form for us, so we can just read it straight from our inequality and graph from there, which says we have a positive 3 for our y-intercept. So let's go ahead and place our first point down at that positive 3. Now we can use our slope of positive 2, and we'll count up 2 over 1, up 2 over 1. Once I've got those two additional dots, I think that should be good enough for me to be able to make the rest of my line, which, since I have a less than or equal to sign here, I'm making a solid line as opposed to a dashed line. Now the last thing I need to address is the direction of my shading. So I have my line portion correct, it's solid, and it's the right accurate line here, and we're saying y is less than or equal to this line. So the equal to implies the shaded region, that the line itself is part of the solution, but we're also saying y is less than this line, so we just want to take any spot on this line and we're just going to shade down below it. So every spot below our line is also a solution here, which gives us our final graph here with our shaded in solution region. Now let's try out an example in number 2 where we don't have slope-intercept form to start off with, so we're going to want to transform our equation until we have slope-intercept form. So we want to isolate our y term, which means we'll subtract that 2x from both sides, and these work the same way as equations. We're just rearranging our x terms as we move them over, and we want to divide by negative 3 on both sides so we can get y by itself, which I'll rewrite up here off to the side. Just one little thing to note: when we have our inequality sign and we're dividing or multiplying by a negative number on both sides, we want to change the direction of that sign. So now we're going to get y is greater than as opposed to less than, and we'll have negative 2 divided by negative 3 gets me a positive 2/3 x, and a positive 6 divided by a negative 3 gets me a minus 2 for our y-intercept. So let's go ahead and plot our y-intercept first of negative 2. And now we still have that positive slope here, so we're going to go up 2 over 3, up 2 over 3. And now for our line portion, well, we can see we have a strictly greater than sign here, which means we're going to want to make our line a dotted line, as the line itself is not included within our actual solution. So now, using my ruler, I'm just going to go ahead and make some dashes along my line, still including my arrowheads here to know that it does continue on, but just dots so that we know it's not part of our solution. Now we can see that we have our line accurately represented, but we know that y is greater than this line, so we want to shade everywhere above the line now to get all the answers that will fall into y being greater than our line. So I would say that looks pretty good for us so far. Let's try an example with our first checkpoint where we are trying to determine the inequality that our graph represents. So why don't we go ahead and have you all pause the video for a moment and see if you can interpret the inequality which is represented here with this graph. So go ahead and do that now, then unpause, we can go over the solution together. Okay, the first thing I took note of had been our positive 5 for our y-intercept. So I just looked at on our graph where our line intersected the y-axis, we got our positive 5 here. After that, the next thing I think we can take from our graph is our slope. So we're starting at that intercept of 5, and then we're counting all the way down, it looks like, till -2, 3 is the next time we get a clear intersection with a distinct grid line there. So that says we're counting down 7 over 3. So we have a slope of -7 and 3 here. So we can just subtract 5 minus 7 over 3x. And we're saying that our y is greater than that line because we have the region above the line shaded. We're also saying that since we used a dashed line here, it is distinctly greater than, and we're not having a greater than or equal to sign. So from there, we can just take our sign and say that y is greater than our line that we just wrote. If you'd like to do this, I know many of you like to have our y consistently on the left-hand side, so we can also rewrite this inequality as y is greater than -7 over 3x plus 5. It's all the same pieces, positive 5 intercept, -7 thirds slope, and y is greater than our line here, just written in a different order. So either two of these options work out perfectly for our answer, so I'd be happy with either of those. But now let's move on to number 2, where we are looking at the distinctions for each of our 4 inequality graphs here, and we're trying to figure out if we can describe what they would look like just based on the inequalities that were given. So starting off, we've got -3x plus y is less than 5. Well, for our shading, we can see that we have a strictly less than sign here, so we know that we're going to get a dashed line. Now let's consider the direction that we're shading. So when we're solving this in terms of y, we can see that we'll move that 3x over to both sides, but we're still going to have a y is less than sign here, so we're going to want to end up shading below the line. Now for our next one, likewise, after we move this -6 over to the other side, we're going to have a 8y is greater than symbol here. So we have a greater than or equal to, which says we're going to shade above the line. And since we have that or equal to component, we're also going to make this a solid line. Now that you've seen a little bit of how these work, why don't you try and do these last 2 on your own, and once you feel pretty confident with what you've come up with, then you can go ahead and unpause the video from there and we'll go over things together. So start off and do that now. Okay, so for this third one we have here, it's a little trickier, where initially it appears that we have a y is less than or equal to sign, but we know when we're isolating for this -4y, we're going to need to divide at some point both sides by our -4, which is going to flip the direction of this sign here. So this will eventually become y is greater than or equal to, which means since we have a y is greater than, we're going to shade above the line. And we know we have that or equal to component, so we need to use a solid line regardless of the direction. Alright, our last one, after we move our 5x to our right hand side there, we can see that we'll have a y is greater than. So again, we're going to shade above here. And now we have a strictly greater than, which is going to result in a dashed line, since our line itself won't be included in our solution.